Welcome to the walkthrough of Assignment 3's frequently made mistakes. First and foremost, please make sure you document and format your code consistently. Too many people are simply writing down a solution and not explaining what the solution does. It's very important to get in the habit of commenting your code. Also, make sure you comment your code in the same consistent ways that we've described throughout the lectures and throughout the other frequently made mistakes videos. Let's take a look at some lingering problems left over from previous assignments. So here's an example where the for each method for the undergrad implementation for assignment 1B was not done correctly in unsynchronized array. In particular, you'll note the comment says to use a for each loop. However, this implementation does not use a for each loop. It uses an index-based for loop. So make sure you follow the instructions. Here's another problem. This problem is showing how the couple of problems here. Number one, this implementation of M0 is way too expensive. There's no need to do the computation asynchronously in the background. There's a much faster way to do this, which was discussed in the video about the basic methods on completable future. So please go back and rewatch that video to see how to do it. Also, this is passing in the wrong value. It shouldn't be passing in null. The value is M0, so that should give you a hint as to which value to actually use. Here's another problem with M0's implementation. This implementation of completable future is incomplete and potentially inefficient depending on how it's used. I believe the actual implementation was used simply incorrectly below. So make sure that you use the proper implementation of this, where you actually give the completed future the value 0. Let's now go ahead and take a look at some problems I saw in a surprising number of implementations of the perform crawl method. The implementation shown here is way too complicated. There's no need to create a completable future explicitly. There's no need to spawn a thread explicitly. There's no need to call complete explicitly, etc., etc. All you have to do basically is call perform crawl async and then make sure that you block until that call is finished. So it's really just a one-liner and very succinct, no need to do any threading and incomplete completable futures and completing them and so on and so forth. So go back and take a look and rethink how to do that because it's too complicated. Here's another example of making the code too complicated. Here's get page async. So this is supposed to be starting up a download of a page asynchronously in the background, but this particular implementation has too many method calls in it. There's a correct call, but then you also do not need to call then apply. So you just need to make sure that you supply the right parameter to supply async, so it'll download the page in the background thread, which of course is what supply async does, but you have to make sure you give it the computation to perform properly. Here's another really weird bug. I'm not quite sure, honestly, why this compiles. I guess it compiles, but the completable future supply async method is designed to return a completable future. There's no need to say new completable future here. So I'm really not sure why this even compiles, but at any rate, you shouldn't be needing to use the keyword new there in this context. Here's another mistaken implementation of get page async. This code actually isn't doing anything asynchronous at all. It's just creating a new future and then calling the complete method, which will block while the page is downloaded. So please go back and rewatch the video on completable future factory methods to learn how to start an asynchronous task. And then it should be really obvious at this point how to do it, but you have to make sure that you do it properly. And this code is not working correctly. We will fix that hopefully in upcoming unit tests to catch that kind of a problem. So here is an example of a problem I saw in a number of implementations. I don't think this would pass the unit tests, so you should have fixed it earlier. But essentially, you have to read the comments above, which I've omitted here, but if you go back and read them, they talk about having a fluent chain of asynchronous completion stage methods. And what you see here are then apply and then compose, which are not asynchronous completion stage methods. So please go back and watch the Advanced Java Completable Future Features video on single stage completion methods, which will give you a very good idea about what you should be putting here as opposed to what's shown in this incorrect code. Likewise, here's an implementation of the crawl hyperlinks on page async method. And again, take a careful look at what the comments say. If you go back and read the comments, they say you should make an asynchronous call to the crawl hyperlinks on page helper method, but this particular implementation is using then compose, which is not an asynchronous call. So go back and watch the single stage completion methods video to give a better sense, or get a better sense of what to use here. Here's an interesting problem I saw a number of people have. They're using the version of reduce that has one parameter, which then returns an optional and then forces you to use the or else method on the optional. That's more work than you need to be doing. You could have a more elegant solution by using the two parameter version of reduce, where you pass in the identity value as the first parameter, which doesn't require you to use or else. Continuing on, let's take a look at crawl hyperlinks on page. This was actually a very clever solution. I'd never thought of doing it this way, and I think this solution will work, so it was clever, and hats off to the people who came up with this. But I think it's also not optimally efficient, because it's going to be doing a bunch of pairwise invocations of then combine, and the order in which things actually finish may not be the order in which then combine is called, so that can actually probably cause more calls than necessary and slow things down more than necessary and just make a bottleneck that's unnecessary. So instead of using reduce in this fashion together with these then combine chains, I recommend you use the collect method together with the to future factor method, which will not constrain the order in which the completable futures are actually triggered. And as you may recall from our discussion in the video about collect and the futures collector and the futures collector stream and so on and so forth, this will end up returning a single completable future that you can then use in conjunction with the then apply completion stage method. And once the single completable future has triggered, that means everything else is done, and then you can go ahead and reduce all the results and sum them up to form the final result, which will come back as a completable future to an integer. So clever approach, but probably not the best way to go. Down here, I see a problem that a number of people made. It's pretty subtle, and you were probably led into the belief, you were reinforced to believe you should be using the async versions of the methods. This particular code, if you read the comment carefully, says return a completable future that synchronously combines and sums the results of the two completable future parameters after they complete asynchronously. So you don't want to use then combine async, which will go ahead and do this computation in another thread in the common fork join pool. Because adding two things together is such a short operation, there's no need to do it asynchronously in another thread. So you can keep it in the same thread and then just use then combine instead of then combine async. And also, I recommend using the integer sum method reference here as the second parameter to then combine instead of using the lambda expression. They're going to be the same performance, but the method reference version is oh so much more concise and clear to the trained eye. Let's now take a look at process images. Lots of people had some interesting problems here. So first of all, you don't need to be using supply async anywhere in this particular method. It's already called in a context where it'll be running asynchronously, so you don't have to use supply async. Moreover, you can merge together all these apply, then apply calls to a single then apply call. So first of all, don't use then apply async because it's overkill. Instead, just use then apply, and you don't need to have multiple calls to then apply. You can just have a single call to then apply. And likewise, you also don't need to filter out the null results because flat map will do that for you. So flat map has a side effect of getting rid of nulls, so that's a good thing. And so you can just use a cast to int and then not have to make the call here to then apply or then apply async. So that's a little cleaner. Let's now go down and take a look at transform image async. There were various problems here. First of all, there's no need to call filter in this case because we're already filtering up here, because if create new cache item returns null, it'll get ignored because it'll get removed by filter, the first call to filter, so you don't need the second call to filter. And then also, pretty subtle point, but there's no need to try to call filter on completable futures. It doesn't do what you think they do, what you think it does. Instead, it'll just basically filter out null completable futures, which should not be happening. So you don't need to call filter here at all because it's not going to do anything in this particular context. Let's take a look at some other problems with transform image async. So here's a little stream that's needed in part of the code, and something very important is missing here. I don't know how this would pass the test. It probably didn't pass the test, so there should be a test failure that you should be fixing. And then here's a whole bunch of problems all wrapped up in one example. So first of all, you should not start doing the streaming of the transforms until the image future parameter completes. And the comments that I omitted here but are in the actual skeletons will give you some hints on how to do this. And so it's pretty straightforward once you know the trick. But don't call transforms to stream it until the image future has completed, until it's been downloaded basically. Moreover, you don't need any try catches in the code. Those can be omitted. The reason that there are try catches in this code is because there's calls to imageFuture.get. Do not use get. Do not use get. You should pretty much never use get, but certainly don't use get in this circumstance because it pollutes your code with the try catch block. And don't avoid the use of the try catch block by using join. You don't want to have any extra calls to join. There should only be one call to join, and it should be way back up earlier in the perform crawl method. So there should not be more than one call to join. Instead, you're going to have to use the collect to future trick to be able to convert things into a stream of basically images. So you want to have this return a completable future to a stream of images. So you'll have to use a different technique here. And again, you don't need to be calling filter in this particular context because you've got the wrong kinds of things to be filtering at this point. And we don't need to be doing filter there. Okay, so that is my walkthrough of the frequently made mistakes for assignment number 3. Many people did well, so that's good, but even when you did well, make sure you document your code consistently and make sure that you're passing all the tests. If you have any questions whatsoever, don't hesitate to come to office hours. So I look forward to talking to you soon.